come in. So, hey everybody, this is Amy Wenzo. We're going to let Facebook kind of build our audience. That's about what it's saying right now. Russell Singer, who's here with me at MakeIt in Alhambra, California, has never done a Facebook Live video. So this is an adventure. Here, come on in a little closer. We're gonna need to get some people. So Facebook is going to build our audience a little bit. So it takes a little bit of time, a few minutes, but we're gonna actually be showing a really cool machine that's running right behind me. So I'm really looking forward to that. And Russell, you were talking about some of the differences on your 3D printing technology versus other machines. What is the main distinction?
Well, basically since we started designing the machine, we were focusing on manufacturing and higher level prototyping applications, where things like reliability and avoiding downtime are actually a really big consideration. So we focused most of our efforts on making sure the machine was durable, that it was highly precise, that it could stand up to kind of workshop type environments where it actually might take some abuse but can still continue running. So that's really the main difference. Our machine is made with the highest quality bearings, aluminum machine parts, stainless steel parts, so it's very high quality materials as well. And there's a couple interesting features too, so we can go up to temperatures high enough where you can start doing more functional materials than older 3D printers used to be able to do. So we can go beyond your basic plastics and do more functional, high durability plastics as well.
Got it. One of the things that Russell was telling me a little earlier, because we were talking about precision. If you were on yesterday's call with Joan Horvath from Non-Scriptum, you might have heard Joan and I talking about the resolution of the printers and the surface qualities, some of those challenges. And these machines, awesome surfaces. There's some models over here we'll show in a couple minutes. And the surface is really, really fine. And Russell, you were telling me that those surfaces are without any sanding, no finishing, straight off the machine, right?
Yeah.
That's so hot. I think that's so cool. Because as a business person, anything we can do to lower operation times makes an enormous difference. So when someone goes for like a really fine surface, it's really smooth off the machine, they're running a higher resolution. What does that do to like the build time of the model?
So the most basic way to think of it is the more layers you have, the longer it's going to take. And if you double the number of layers, it's going to take about twice as long. There's some trade-offs that don't make it quite that linear, but that's pretty much what you're looking at. So we tend to advise people to choose their layers in a way that makes sense with the scale of the part that you're printing.
Right.
So for example, something very small like this. So this is printed at 20 micron layers. It's 0.02 millimeter layers. And the layer lines are basically indistinguishable. But with a part this small, you're not going to spend so much time printing it. It's only about a 30-minute or 40-minute print for something like that.
And on something like this, you couldn't even sand it. I mean, there's just physically impossible to do.
Right. But then if you're doing something like this, which is obviously much larger, this is printed, I think, with 0.2 layers. So this is 10 times rougher resolution.
Yeah, and
but in the scale of it, it still doesn't look too bad.
Yeah, you can see some of the layering. But you know what? This is really pretty good. And this is extremely lightweight. This is hollow.
It's almost hollow.
Almost?
There's some infill inside it.
Yeah, I mean, this is really, really lightweight. So this is, I mean, seriously, your kids could have moved this around in space. You could do a chair like this and the kids would love it. Okay, so we've got a tiny thing that is literally probably 3/8 of an inch diameter. Mm-hmm. That cap's probably 3/8 tall, I would guess.
That's our part.
That's actually
this is what's
the
running?
control dial for the printer.
Okay, so you said something really neat earlier, and that was that the resolution of this machine is so good that it actually can 3D print some of the parts of the 3D printer.
Yeah, that's actually, it's interesting. Early 3D printers that were of the desktop format, that was actually a really big part of it. People who were making the earliest at-home 3D printers were doing it with their own 3D printers, and there was actually a goal to make a printer that could completely reproduce itself.
Yeah.
that's not really realistically attainable, but as a small business, the same idea helps us produce a lot of parts for our own printer. So things like some of our bearing mounts on the x-axis, these are actually printed in a PETG plastic, which can give us a very high resolution part and very fine finish quality, but it's also a very durable part. So we can press fit the bearings in there, and it can withstand that pressure and actually do a great job at it.
Wow. So you're 3D printing parts for your own machines, and you were telling me that these machines are actually designed to run continuously.
Yeah.
So they're designed for a small production run kind of manufacturing.
Right, so we have, there's a couple interesting features. So we have 2 nozzles on all of our printers. So if you're making small parts like that one, you can actually double your production speed because you can run 2 parts at the same time.
Oh, okay.
And that's extremely useful for a lot of small businesses. If you're making bracketry, adapters, or the kind of parts that we use in our own printer, we use that for all of our parts, we duplicate them. But there's also just the reliability of it, the way that we do our heating, the fact that we have a thick aluminum bed that carries very consistent heat. We run these things for sometimes 60 or 80 hours without stopping. And something like some of the products that we have in here, like some of the parts for the table or those tall lamps, might go for 100 hours.
Wow. So
yeah.
let's show these. I'm going to take this for a second. So everybody, this is really, really cool. And so tell me about this model. This is like a little miniature Parthenon.
Yeah, I think it's one of the temples from there. I don't know if
It might be the Temple of Athena.
It might be, yeah.
But seriously, look at the resolution on this. It's pretty amazing. So to give you an idea, that's what, maybe 2 inches tall at the most?
Yeah, about.
And to look at this, I mean, you can see the surfaces. They're really, really good. So I'm sure we're going to ask, because they do, you know, about what would a printer like one of these run.
So we have 2 models. The ones that we were just looking at in the video are $44.99. Our lower cost model, which is smaller, it comes with a few less accessories, is $28.99.
And what size build plate are they?
So the large one is 10 by 12 by 13 inches tall, and the smaller one is 8 by 9 by 8 inches tall.
That's really good. And if you can assemble the parts afterwards, which you always can,
right,
you can definitely fit some interesting things. Let's show these other samples of plastics. Let's go over here. So these are all the materials that your machines will run, right?
It's a subset of the materials. So our machines are open compatible with pretty much any filament that is the right size and prints at a low enough temperature for our machines. So we can go up to 275 degrees Celsius, which allows us to print high quality plastics like polycarbonate, which is down here. So polycarbonate is a really nice material. It's very durable. It can give you some flexible qualities. This is an interesting one. It's a thermoplastic elastomer, so it's actually very flexible. You can make nice soft parts with it. It's another example.
So if you were
here,
doing like a wearable tech and you wanted to prototype it, this could be a really interesting material to work with.
Yeah.
And that's
the same material as you see there.
So this is actually almost as plasticized and rubberized as like some strap material, but you really kind of have to be careful if you're using this kind of material for prototypes. Everybody pay attention. Don't count on it taking a whole lot of abuse. You know, it will demonstrate principle, but it's not the same as a rubber strap that you get in production, you know, for most of it. But
there are definite trade-offs, and there are cases where 3D printed parts are not applicable. I'll 100% admit that. There are trade-offs with the printing process, and just because of the way it lays down layers, 3D printed part is very directional. If you try to use a 3D printed part where it's taking the stress in shear along the layers, it'll break much easier than something like a more traditional material like metal or wood.
Right.
But in the right applications, they're very usable, and it can actually be really helpful. So like here we have an example, this quadcopter drone right over here.
Here, we'll do it that way.
That's actually a kit that is sold, and it's sold with a number of 3D printed components with it. So it's a combination of carbon fiber and 3D printed parts. 3D printed parts are used to mount some things, mount the camera, the landing gear, aerodynamic components.
Right.
But it's actually sold with the 3D printed parts.
Can we pick this up and move it
yeah,
around?
Please do. Yeah.
Awesome.
And so, his customers actually appreciate having the 3D printed parts because they're easy to replace if they get broken, which happens in flying drones.
In flying drones and quadcopters that crash.
Yeah. Right.
So,
but other things too, like so this is actually a PLA based material. It's this here. It's wood fill. So it's actually sawdust that's suspended inside the 3D printed part. And so then you can sand it and finish it like real wood. So this is sanded and then stained with wood stain and then clear coated. And something like this, I've actually had this, I took it out of my car. I use this on my transmission in my car. It's been there for almost a year.
wow.
Yeah.
Same finish the whole time?
Yeah.
So it's held up really, really well. I love that you took that out of your car. But, I just want to say how much I really appreciate Russell taking the time. Doing an open house takes effort and it takes time away from your business. So thank you so much. This is Amy Wenzel and Russell from MakeIt talking at Connect Week. So everybody, big shout out, big thank you to Russell. If you want to look at machines, I'm sure they'd be happy to talk to you. Russell, how do they find you guys?
You can find us online at makeit-3d.com. Or information at makeit-3d.com is our email.
Awesome. Talk to y'all soon. We'll be at another session later tonight. Bye. Okay, so it'll be whatever it is. But
I was listening, it sounded great. So.
it's like
How does that get messaged out to people? Is it
it's
actually
already
live?
up and live.
Like,
It's done. People were watching.
really?
Oh, did it show you how many live viewers?